Hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says count subarray with k odds. The problem statement goes like: you are given an array ARR of positive integers and an integer k. You have to count the number of subarrays that contain exactly k odd numbers. Okay, so we have to count number of subarrays. That's a problem. Case 2 for this array within an example, and we wanted to find arrays who has exactly two odd numbers. So does this has two odd numbers? No, yes, it does have two odd numbers. So we have one count as this, another count is as this. So yeah, we got that count. How are we going to deal with this? How are we going to find it? So there are two optimal solutions, but before jumping into optimal solutions, let's see what the brute force solution says us. How can we solve this if we didn't care about any optimizations? So the logic behind this brute force approach is that hey, I can run two loops for I and for j you would have the next pointer. So that would give you a range that is from I to j, and then you will go ahead and check whether it is. Then you will go ahead and maintain a odd count and get to know that hey, whether it is a target array or not. So here is the time complexity for this solution, which is n square, which is not very optimal, but can we improve this one? Turns out that yes, we have not one but two optimal approaches. Optimal approach 1 and optimal 2. So let's take it one by one. Optimal approach 1. You see, you wanted to understand the count. Let's understand it by an example. Count of odd with k is equal to 2 for this. Now k is equal to 2 here. The index is 0, 1, 2 and 3. Let's understand how we can see this count. Like till this point, if the array was of size 1 to 3 only, which means I have array containing such elements as 5, 6 and 9, there would be only one. Answer is equal to 1 because there is only one subarray which would have count of odd numbers as 2. But the insertion of 2 was very like 2 just disrupted the change. Now we wanted to maintain count right now. So what I'm saying is, let's have a map. What I'm looking for is a map which would store the odd count in array. And in array, when I mean in array, the array seen so far, which would map to frequency. Frequency means how many times I have seen this count. So here in this case, it is 0. Right now I have not seen any odd number. This is odd number, cool. I have seen one time. This is even number, so I have seen one time odd numbers twice, and ultimately I have seen 2. So with this in our mind, the array would look like 0 odd numbers, I'll give it later upon. 1 odd numbers, how many times I have seen this? I have seen 2 times. And 2 odd numbers, I have seen it 1 time. Like this I'll go with this map. For 0 odd numbers, what do I have? I'll have 2. Why? Because you see, for index 0, we have, that is 2 here, that is value 2, we have an even number. So odd count is 0. But what if I don't consider any array? So I am not considering any array, so no number chosen. In that case, I have 0 odd count as 0 and odd count for 0 for no choice. So no choice making is also a choice, and taking 0th index is also a choice. So we have 2. Cool. Now I've created this. What is the use of this now? So see, the use of this map is very crucial now. Till now, we came to know that how many times I have seen 2. So 2 I have seen 1 time. Now I'll ask you how many times I have seen 1 till the point of this array. This point. So you'll ask me that hey, the count of 5 was 1. This contributed from 5, and I wanted to have next one. Can I get next one? Yes, you can get next one. You can get next one with the help of 9, which is next yet to come, and that's the reason I would increment that as well. So this contributed to result, and this will contribute to result upon considering. I know this might sound confusing, but wait a while till we go ahead into code. Things would become much more simpler. So I'll jump into code so that to avoid less confusion and more simplicity. So as usual, I wanted a map. I'll take a map, integer to integer, a map of new hash map. Again, what it will store? It will store odd count to frequency seen so far. Cool. I wanted to add a static value, map.put 0, 1. That means base case. It is a base case where 0 odd seen once. So we have seen 0 odds at least once now. I'll go ahead, int odd count is equal to 0 right now, int result is equal to 0. This result I would be returning in the end. Odd count is nothing but odd count seen so far. So I'll just move from int I is equal to 0, I is less than a dot length, or I'll do a better thing. I'll use a for each loop for n in a. Now I wanted to check this number. I'll check this number if n is odd is equal to 1, then I will increase the odd count. So simple. Now increase the odd count. Now check if I have any complement. What do you mean by complement, by the way? A complement is nothing but what is required for me to complete this. So if I'm having odd count right now as odd count, what is the target I need? Which should be k minus odd count, or odd count minus k. That means let's see, if I'm having let's say odd count, my array size is very much big. So you see something, and here we have array sizes 100, 101, 2003, and till this point I have seen 50, 30 odd elements. I have seen 31 odd element here, but my k is equal to 2. I want only two elements. In that case, what I'll do is, I wanted from 31, I wanted to look forward for that element somewhere previous to it, which would give me the count as, the count should be as 29, I guess. Yeah, 29. So 29 plus 30 plus 31, that means plus 2. So from 29 to this 31 I'll get, and there can be multiple 29s, agreed, multiple 29s can be. So what I'll do is result plus equals to map dot get or default target. So if you have this target, then that's good. If you don't have target, yeah, sure, return 0 for me. I'll add 0 to my result. And ultimately what I'll do is I'll put the odd count within the map, since we have seen this order, right? We have seen this order, so map dot get or default odd count comma 0 plus 1. Cool. I am checking, then I am filling. That's a good part, and I'll do it for rest of all the numbers. What I'll get a result in the end. Let me compile this code. Again, this is not a very optimal solution, but this is a cleaner one. Integer, what's wrong here? Hash mao, no, hash mao is a hash map. Okay, it passed the sample test cases. Let's test for rest of the test cases as well. Cool. It passed, but are we going to stop here? No, we are not, because it takes O of n space complexity, and we want space complexity of O of 1. How are we going to deal with this? Interesting. Now, the solution is very simple. How are we going to deal with this is, we don't want it to use the map. So if we don't want to use the map, what are we going to do? Obviously, we wanted to understand the problem again then. How are we going to approach this problem? We wanted exactly k, what do you say, odd elements. That's where we are having a pain in ourselves. That's the painful process, because the array is 31, and if I want 2, beyond k is equal to 2, then I can count each and every array post I have seen 2. Isn't it right? Yeah. But that is not how we are going to do. It is not the case of at least or at most. If it was at most, then that would be much more simpler. So I wanted to find at most k elements for this, then it would be much more simple. But I want exact k elements. So how can I get exact k elements? Exact k. So exact k for this k, what I'm having is, I can do one thing. At most k I will get minus at most I will have k minus 1. Will it make sense then? Will it make sense to do this? Because here I'm having at most k. In our example, I'm saying that, hey, I want at most 2 odd elements, and I will get the array of size, how much? Array of size 1. Max to max I'll have how many elements? Like up to 2 elements. So 1, 2, 3, whatever it would be. So this would be at most k, yes, 1, 2 elements, 3 elements, 4 elements. So here I am having 4 elements, minus at most k minus 1. That means at most 1 element, and then I wanted to stop. So 1, 2, yeah, 2 elements here. So 4 minus 2 is 2. So now we got the drill that, hey, I wanted to have at most k elements, then I can go ahead. So that's a good one. Let's start this approach then. If I wanted to get k and k minus 1, it would be just 2 implementations here and there, but things would be simpler post that. So I'll quickly go ahead and remove this code, but instead I would have at most k minus at most k minus 1. So this would be our logic to go for it. Again, for at most I wanted to code, it will give int at most, it should accept int k and int array as well. Without an array, how can I compute? That's also a thing. So I need an array a, I need an array a here as well. So yeah, let's start with this one. If k is less than 0, it's a base condition, I'll return 0, and I'll have a start pointer which is 0, and this is very similar to sliding window. If you have not introduced with a sliding window, I'll highly insist you to go ahead and click the video here. You will get to know about what sliding window is, and you will get to see how basic problems is solved within sliding window. So odd count is 0 initially. Now our loop begins. What I wanted to do, I wanted to go from end is 0, which is, yeah, it is 0 only. End is less than a dot length, end plus plus. Now odd count I will update plus equals to if the number is odd or not. How can I check? A of end ending with 1 will give me correct. Yes, I'm using bit operations here. And while odd count is greater than k, that means I have excessive elements. Shrink the window. How do I shrink the window? By removing odd counts minus equals to a of start and 1 ending with 1. So if start 1, the element at the start was odd, then only I'll remove the count, which would affect the while loop condition, and if the while loop condition is broken, then I'll move out. Also wanted to update the start pointer, and this is how I shrink the window. Once I've shrink the window, I'll count how many elements are within start and end. So I have start pointer, I have end pointer. I'll count just e and e minus start plus 1 because I'm counting both the elements. So e and e minus start plus 1 would give me the count of elements within the array, and ultimately I'll return this count. Let's compile this one and check it out. Okay, bunch of mistakes here and there. I don't have a count variable. Let's have a count in cnt is equal to 0 initially. Cool. Yeah, it got accepted for first test case. Let's see for rest of the test cases. Yeah, it is submitted. So we have addressed both the solutions, and the optimal here is with the auxiliary space solution, where we have at most element consideration, and once we have at most element, we remove them from our preceding. So this was all about it. This was a part of a sliding window. We also checked with a prefix sum and 2 pointer algorithm simultaneously. And for more such kind of awesome content, click the video on your right, and I'll see you in the next one.